Good afternoon, everyone. We are lucky to have Dr. Kelly Kopp as our presenter today. Dr. Kelly Kopp is a professor and extension specialist, if you don't know her, in the Plant, Soil, and Climate Department at Utah State University. Her research focuses on landscape water conservation and sustainable turf grass management. She is also director for the Center of Water Efficient Landscaping at Utah State University and has important roles in numerous national and international water conservation agencies. I can't name those. It's way long. She has played a vital role in educating about not all turf are same, and yes, we can still have turf and conserve water. Her excellent research and extension work are widely cited and greatly appreciated. Without further ado, it's all yours, Kelly. You can take it from here. I will minimize myself and turn off the video and mic.
Thank you, Sital. This is, I appreciate that introduction. Sital is a fantastic colleague in our Center for Water Efficient Landscaping. All right, well, I am going to share my screen so that we can get started. And the title today, and I appreciate Sital's assistance in coming up with this, but really redefining lawns, or at least that's what I would like to do. I would like for us today to consider what lawns actually are and what they really are not, and how that relates to the benefits and sustainability of managing them, and more specifically, managing functional turf grasses in our landscape. So first, probably what we should do is just talk about some definitions, or how at least I'm defining functional turf grass here today. But before I even get into that, I did a little bit of research about grasses on this planet, and I wanted to share some of that with you. One of the facts about grasses on this planet is that there are more than 11,000 species of grass on Earth. They grow naturally on every single continent and in almost every terrestrial ecosystem. They're a huge contributor to food production. You may not have thought about this, but things like wheat, rice, those are actually grasses. And so as such, they contribute to some of the top food production crops in the world. And among those that are those top contributors, 3 contribute as much as 60% of human caloric intake across the globe. So obviously they are very, very important from a food production standpoint. Now, having said that, of course, I'm not here to talk about grasses as a food crop, but I think a lot of people don't realize what a broad community of plants this is. I'm here to talk about functional turf grasses with you, and those are the grasses that we have in our urban and suburban landscapes. And I'm talking about plants, grass plants, that is, that function as a ground cover and regularly receive traffic for recreational and or functional uses. There are 20 perennial grass species that we use in this way, and these include grasses for home lawns, athletic fields, golf courses, more reclamation type purposes such as roadsides and things like that. But there are about 20 species that we use in this way. And while these grasses may not feed us, they do perform a number of very, very important ecosystem services and have a number of environmental benefits. So things like helping with soil erosion, helping reduce soil erosion, preventing wind erosion, reducing stormwater runoff, among many others that you see there. And I'd like to talk, before I get into the heart of the presentation, I'd like to talk in a little bit more detail about some of these that I consider to be very, very important. So starting with soil protection, the world's best, and by that I mean most productive, but the world's best soils actually evolved under grass cover. And the reason is that grasses, as they're growing, deposit carbon into soils through their root systems. So as roots develop, grow, and then die, that carbon is integrated into the soil, and that then becomes a way for the soil structure to improve, a way for air and water holding capacity to improve, and just improves overall productivity. Now, in today's urban ecosystems, where we often have native soils, urban and suburban, I should say, where we often have native soils that are disturbed, disrupted, grasses are often used to help restore those areas. So they help bring soils back to healthy conditions in some of those situations. And in fact, the US EPA often recommends grasses to cover construction sites because they do protect soil. They keep that soil in place. And soil erosion is a big issue that we have. And, if you're interested in turf, you may not have thought about this too much, but turf grasses that protect soil from erosion protect that soil health and quality over time and keep soils where we want to have them. Another really important ecosystem service or environmental benefit of turf grasses is stormwater retention and biofiltration. And what I'm talking about here are excessive amounts of moisture, which could be due to excessive rainfall, could be due to excessive snowmelt, which is something we've seen quite a bit of here in our state recently. And they can also be the result of excessive irrigation, which of course is absolutely what we do not want, but that sometimes does happen and can create stormwater issues. So stormwater sources can contain a whole lot of different kinds of contaminants, things like antifreeze, things like grease, oil, because stormwater is often coming off of hardscapes, things like streets, sidewalks, etc. But they can also include things like fertilizers and pesticides and other chemicals from home and landscape management. They can include bacteria from pet waste. They can include bacteria from failing septic systems, sediment from poor construction practices, all kinds of things. The point being that these waters can contain pretty significant amounts of contamination. And that is why grasses are often used in retention basins, and other stormwater facilities. It's because grasses in those kinds of situations can retain that water on site. They can slow it down so that it has time to infiltrate into the soil. And because they have such extensive root systems, they are very well able to especially take up nutrients, but also to retain, trap, contain the contaminants that I've mentioned. So they perform a really important ecosystem function in that way. And we have data to show that a 5,000 square foot lawn, for example, can capture between 2,000 and 27,000 gallons of water over its surface area, depending on the type of soil and the type of turf being grown. So that is a really significant amount of water that can then serve to protect our other waterways, our streams, our rivers, our lakes that are all downstream. Another really important benefit of grasses, and this is true of all other plants too, is that they produce oxygen. And frankly, sometimes when I hear people talk about turf grasses, it makes me wonder, are you even talking about a plant? Because you seem to have forgotten that it functions as a plant to produce oxygen and do a number of these other things that I'll be talking about today. So like I said, like all plants, grasses produce oxygen, which helps us with the air we breathe. They also absorb carbon dioxide, which I'll get into more in a minute. But that is true as a general statement, but we also know that many factors influence how much oxygen turf grasses produce, and things like temperature, light, moisture, etc., and the varying types of photosynthetic pathways grasses have. So think cool season versus warm season grasses. Those all affect how much oxygen is produced. And we also know that, again, a 5,000 square foot lawn can produce enough oxygen each day for anywhere from 14 to 34 people. And this is data-based information. So to put that in a little bit of context, that for some cities that are relatively close to us here, at least in Utah, and actually close to some of you who are here on the Zoom with us, but Los Angeles is a city where a 5,000 square foot lawn can produce oxygen to support 28 people. Dallas would be another city, and that a 5,000 square foot lawn can produce enough oxygen to support 34 people. And it just varies depending on where you are in the country. We don't have local information for us here in Utah just yet. And as I read this research, I know why. It was because at the time of the study, we did not have a sufficient number of quality weather stations within, let's just use Salt Lake City, for example. We didn't have enough weather stations within the Salt Lake City area proper to compare to more rural areas where these other communities that were part of the study did. However, having said that, we now do have weather stations in Salt Lake City. USU Center for Water Efficient Landscaping actually helped them to install an additional 4 weather stations there. So there are now a total of 5. So this is the kind of information we'll be able to develop. Moving on, one of the really important benefits that we get from grasses, especially in the southwestern part of the US, is atmospheric cooling. And we get a lot of atmospheric cooling in our landscapes, primarily from trees and grasses, and they help with atmospheric cooling. In the case of trees, it's largely because of their shading. In the case of grasses, it's actually because of the evapotranspiration that grasses do. That serves to cool the atmosphere. So plants in the landscape, grasses in the landscape, they help to moderate temperature around our structures, which is really, really important because those cooling effects reduce temperatures in structures, and that significantly reduces energy use, which reduces cooling costs and the associated carbon emissions from power plants that are providing energy for that cooling. So there is actually water embedded in energy, and so it becomes a really important additional way to save water. Some interesting research I came across as I was preparing for this webinar too, I also wanted to share with you. And that was a study of increasing heat island effects that we're seeing in our urban communities. And this study focused on a 10-year period between 2004 and 2014. And what they found was that in 57 of the 60 cities that they studied, there has been an increasing heat island effect. The worst case being Las Vegas, where their summer heat island effect has increased 7.3 degrees just over that 10-year period. Some other communities where they've had significant increases, Albuquerque, Denver, and you can see the increase there. But that begs the question, when we are talking about making changes to landscapes and when we are talking about turf grass removal programs, what are the potential negative unintended consequences? And I would argue that those are quite significant. Now, the other thing that I really wanted to talk about in terms of ecosystem services with grasses has to do with carbon sequestration. And again, when I hear people talk about turf grass as though it's not even a plant, it just makes me wonder. So, like every plant out there produces oxygen. Plants out there also help to sequester carbon, and turf grass is no different. They sequester carbon in their roots, and as those roots die, that carbon becomes a part of the soil carbon process, and it keeps that carbon in the soil. And when we talk about carbon sequestration, that sequestration can happen in different places, but a lot of it can happen in the soil, and turf grass can facilitate a lot of that carbon sequestration. And we're starting to have been some studies, and I'm actually starting to conduct some myself to quantify the amount of carbon that can be sequestered in turf grass landscapes. But some of the existing research has shown that from 25 to 200 grams of carbon can be sequestered per every square meter of lawn on an annual basis. And, that might not seem like a lot if you're looking at a single lawn, but when you look at the entirety of lawn across this country and the potential carbon sequestration that could occur, then it does become significant, and it does have the potential to reduce the country's carbon emissions significantly, or at least counterbalance those emissions. And another study that I found as I was preparing today found that lawn grasses in at least one U.S. metropolitan area accounted for about 50% of the carbon captured in that particular city. So, again, we're talking about functional turf grasses here, and I'm certainly not saying that we need them everywhere. But I am saying that they do provide these important benefits. And so we need to consider that when we are talking about how they are used, where they are used, and whether or not they are used. So with all of that as sort of a bit of a lengthy introduction, I'll get into what I plan to talk about for the most part today. And I'm going to be discussing water resources, of course, a little bit on turf grass water use and physiology, how we optimize that water use and physiology, that water use efficiency, and then a little on irrigation scheduling and wrapping it up with some information on turfgrass species and varieties. So we continue to have water resource challenges here in Utah and in the southwest region of the country, despite the fact, and some of you may not know this, but we have just come out of the biggest winter on record in terms of snowfall. And so we've had an incredible winter that is allowing us to refill many reservoirs that have been low for many years at this point. However, I have a climate science colleague who said that despite this fantastic winter we've had, we would need 9 consecutive winters like the one we've just had in order to completely come out of the drought that we are currently in. He also then said that this was a statistically impossible thing. And so I guess what that means to me is that we still have plenty of work to do despite this great winter that we've had. And in addition, we continue to have a growing population. We continue to have water quality issues and a lot of competition for water resources. So last summer, things were quite a bit different. And you can see here in the southwest part of the country, we had a lot of area in extreme drought and exceptional drought, and it was a pretty difficult situation. Obviously, things are quite a bit better at the moment. But again, very unlikely / impossible that we would have 9 consecutive winters like we've just had. So water resources remain a big challenge for us. Now, in terms of water and turfgrass physiology, and again, I will not spend too much time on this. I suspect many of you are not here for a plant physiology class, but water does perform very important roles in turfgrass physiology. So it's a transport medium for water for sure, but nutrients and other things that the plant is moving through as it transpires. So it is moving water and nutrients from the soil through the plant, and then there is some transpiration through the leaves. Water helps keep cells turgid. It helps open stomata, which is how plants release oxygen and take in carbon dioxide. Very important for photosynthesis. It serves as a solvent and a catalyst. It's also an end product of respiration. And so just a whole host of very, very important plant physiological functions. Now, that's the plant side of it, but we typically are thinking about turf in relation to soil and water. So as a system, how does it function in that system? We know that carbon dioxide is necessary for plant processes, again, because turfgrass is a plant like every other plant, but there is water loss during that process. And so that's evapotranspiration, and that's what we're typically trying to replace when we irrigate. Plant roots have a role. The xylem of the plant has a role. Cuticle, stomata that I mentioned, all have a role in that evapotranspiration process. And then water in the soil moves from the soil through the roots and the plant in response to physical, and by that I mean physics, physical forces and differences in physical forces between soil, plant, and atmosphere. So that's how water is moving through the system. Now, when we're talking about meeting turfgrass water requirements, of course, there are going to be many factors. Species is one. Beyond species, and we can talk about this more, but beyond species, within species, there are literally hundreds of varieties of species that can be considered. And so if, for example, someone says to me, well, Kentucky bluegrass is a high water use grass, period, I have to say, well, actually, that isn't the case. The fact of the matter is that Kentucky bluegrass water use is widely ranging depending on the variety that is used and where it's used and how it's managed, etc. So I'll get into more of that as I'm going on. It also matters how the grass is being used, the function of the grass. So, for example, I have a lawn area at my home that my dogs play on, my kids play on, and so it gets traffic, but it's also not an NFL game, right? So how it functions matters, how much traffic it gets matters, where it's located and the climate in which it's located, whether that is, just day to day or more long term, that is also going to be a factor. Evapotranspiration will also be a factor which is impacted by all of those things I mentioned. And the relative drought tolerance, which is also very, very affected by the particular variety and species of grass being considered. And then, of course, management practices. We can't control probably 99% of the things in our lives, it feels like some days. But we can very much control how we manage landscapes and how we manage turfgrass areas with the goal of optimizing water use efficiency, but then beyond that, optimizing those ecosystem services that I mentioned at the beginning. Now, this is certainly not a comprehensive list of turfgrass species characteristics, but I want to show it because it illustrates the difference in all sorts of management requirements for different species. So, for example, blue grama grass is considered to have a low water requirement, moderate to low fertility requirements, high drought tolerance, low shade tolerance, et cetera, et cetera. And having some understanding of this is fantastic when you're trying to decide whether and which type of turf grass you might want to have in a home landscape or a community. We're working with whole cities at this point on what kinds of grasses will be best for them in terms of water use efficiency. This is a very broad brush stroke of what they require, but just to give you a sense of the difference. And this doesn't even begin to incorporate the difference in varieties, which, as I said, can be incredibly important. Now, one of the things that we offer through our Center for Water Efficient Landscaping and USU Extension are informational support of various types. This webinar is one of those, but we also have a number of different fact sheets, videos, other types of information to support efficient turfgrass management practices. So things like incorporating ET into irrigation scheduling. And speaking of ET, we also know that turf grasses have very different evapotranspiration rates. And again, this is very broad here. This is talking about species in a very broad capacity and does not consider individual varieties. But in general, we can talk about cool and warm season grasses and their different water requirements and how they differ in terms of evapotranspiration. So again, just to illustrate how different they can be. Now, we can also consider drought tolerance, and we know that warm season grasses are more drought tolerant than cool season grasses. And then even within those two broad categories, there are very different drought tolerances. So for example, with the warm season grasses, Bermuda grass is considered the most drought tolerant. That is one of the reasons that I and other colleagues in the state are working to get it removed from our state's noxious weed list. It is a very water efficient grass. Buffalo grass is another, zoysia grass is another, and that's a grass that we're currently doing some work with and finding some good cold tolerance, despite the fact that it is a warm season grass. On the other side here, we have a number of cool season grasses that have a range of drought tolerance. The wheat grasses, they are native to this part of the country. They tend to be the most of the cool season grasses. But again, the warm season grasses are more drought tolerant than the cool season grasses overall. So I want to spend a little bit of time talking about optimizing water use efficiency for turf grasses, and that really begins at the beginning or the establishment phase with grasses. And we have, again, a number of forms of informational support when areas are being prepared for establishing turf grass, and these are geographically specific for us in the state of Utah. But this type of information, I know many of you are not in Utah, and this type of information exists for many other locations in the country as well. And if we come to the end and you have questions about locating that resource locally, I'm happy to chat with you, or you can email me and we can discuss it that way. But proper preparation is one of the very best things that can be done. You may recall I mentioned in the very beginning that grasses are often used to help recover very disturbed urban and suburban areas because of the disruption with construction, heavy equipment, things like that. And so we know that they can be used for that purpose, But we also know that if we can have a very good soil condition when we start our turf grass areas, that is very good for optimizing water use efficiency down the road. And in fact, I would say, I've been doing this quite a while at this point, and most of the problems that I see with turf grass areas have to do with inadequate soil preparation, low quality soils, inadequate depth, things like that. So it is very, very important in terms of later water use efficiency. Now, other management practices are also very important. Things like mowing. The different grass species that are out there are ranges in mowing height that we recommend, but my general recommendation there is that if we mow on the higher side of that range, so here, let's just look at Kentucky bluegrass, for example. We recommend mowing as high as 3 inches, and I would actually go further than that and say mow it as high as your mower will go or as high as you can personally stand in terms of aesthetics, because 3 inches is great and it's much better than most people do in terms of what I observe in the world. But I can also share with you that here on our university campus, the mowing height is much higher than that, typically anywhere from 4 to 6 inches. And in that way, they have been able to reduce their water use in a big way on turf grass areas, because there is a direct relationship between turf grass mowing height and rooting depth. And the higher you mow, the deeper the roots will grow. And so those higher mowing heights are a very good idea in terms of optimizing water use efficiency in turf areas. There are some things just to keep in mind, though. With those higher cuts, we've got more leaf area, right? And more leaf area means there are more stomata to transpire, I should say. And so with that added plant surface area, we can have somewhat increased water use. However, with low cut turf, we reduce that, but you also have the negative repercussions as far as rooting depth, right? And so if we want to encourage that deeper rooting with the purpose of accessing soil moisture deeper in the profile, we need to keep this mowing height in mind. And so it's really a balance, right? It's a balance between a higher mowing height that is aesthetically acceptable, logistically possible with mowing equipment, and also has a height that is sort of optimizing that water use and not reducing rooting depth. So you want to be at that point where you can enhance rooting depth and extent so that but at the same time, keep that leaf height, I should say, as close to that cutting height you want as possible. And in that way, you're going to reduce ET while increasing extraction of soil moisture. And so there, the bottom line really is mow higher, but mow more often. And in that way, you're taking off small amounts each time that you mow, and that is the optimum in terms of overall turfgrass water use efficiency and health. Now, another really important management factor to consider is fertilization. And fertilization, of course, we know is going to influence turfgrass growth, but it definitely also influences water use. And we often fertilize because native soils do not have an adequate amount of nitrogen for many of our landscape plants. At the same time, we don't want to overdo it because excessive fertilization of turfgrass creates high evaporative demand of that grass, and it's more prone to wilt. And so we're trying to avoid that as well. But depending on how you manage, particularly nitrogen fertilization with turfgrass areas, you can reduce water requirements while optimizing turfgrass health, and having sort of the best of both worlds type scenario. Now, having said that, when nitrogen in particular fertilization is excessive, that does cause increased water use because you have a whole lot of leaf growth in response to that excessive nitrogen fertilization. And up to a point, that's okay. You're still getting some benefit from that fertilization. But you get to a point where that levels off. And then at that point, it actually suppresses or stops root growth. Why is that a problem? That is a problem because if you have a whole lot of leaf growth because of that fertilizer application, but the root growth has stopped, those roots are then less able to bring in the water that those leaves require. So it's sort of a vicious cycle of I need more water, but I don't have the roots, but I need more water, but I don't have the roots. And so that's a situation that should also be avoided. And on the positive side of that, there is often terrific information locally. And I know that we have this information locally on how much nitrogen nutrition turf grasses actually require. And so, again, I'm happy to help you locate that information for your location. But nitrogen isn't the only part of the story. Potassium and phosphorus are also very important. Potassium in particular helps with improving drought recovery. It can increase rooting mass, which is also very important for drought recovery, and decrease wilting tendency. And in combination with nitrogen, we know that phosphorus improves drought recovery. And iron can also increase root production and reduce desiccation injury in combination with nitrogen. The other thing to think about here, and I don't have time to get into it too much, but one of my favorite topics is turfgrass clippings. And that's because turfgrass clippings can perform a number of functions, including improving the nitrogen status of that turf soil system, and also increasing the organic matter content of that system, which in many parts of the Southwest is a big issue. And then sort of the last thing I wanted to say about nitrogen is that applying nitrogen in the fall actually does more for drought recovery and response the following year than any other fertilization you can do. And so that's why I have often been heard to say that if you are only going to fertilize once per year, it should be in the fall. All right, moving on now to irrigation, which is where I wanted to spend the majority of the time. So irrigation scheduling, of course, is very, very important. And what you see there is a social media campaign that we were involved with quite a bit last year when we were in much deeper drought. But of course, the message there is wait to water. And that was wait as long as you possibly can at the beginning of the growing season so that plants can take advantage of soil moisture deeper in the profile. In the case of turf grass roots, they can be encouraged to grow deeper. And then just some general things that we often recommend with irrigation controllers, for example, sensors that will shut it off during rain, during frost events, during wind events, cycling irrigation so that there isn't water loss to runoff or deep percolation, and then matching the application rate of water with the soil infiltration rate, again, to avoid runoff. And then considering temperature and wind when scheduling irrigation. So a number of just general recommendations that we can make. Now, we also can discuss low-tech solutions for improving water use efficiency in turf areas. So things like minimizing overspray, which is irrigation water that lands where you don't want it, sidewalks, streets, etc. Monitoring water pressure. In terms of irrigation systems, water pressure is the number one variable in terms of efficiency. And I can tell you, after having done thousands of audits here in the state of Utah, that our water pressure is all over the map. In some places, it's extremely low. In many places, actually, it's extremely high. And so moderating that pressure can be very helpful. Designing irrigation systems to compensate for wind, or scheduling irrigation to compensate for wind. In Utah, and I suspect many other places too, we have times of the day that are windier than others. And so changing your schedule based on that can be incredibly helpful for making sure the water lands on the plants and not in the street or on the sidewalk. And then routine maintenance, which of course is going to help improve the efficiency and uniformity of irrigation application. So, fixing leaks and breaks, leveling heads, unclogging nozzles. We have an extension irrigation auditing program here in Utah that we've been conducting for many years. And we consistently see 20 to 30% water savings from our participants because we help them identify problems and recommend solutions so that their system is much more efficient. Now, there are, of course, higher tech solutions. There are moisture sensors out there, soil moisture-based irrigation sensors and controllers. We sometimes use subsurface drip irrigation for turf areas. We've got a terrific demonstration area of that out at our research farm. We also have integrated weather and irrigation systems. So I'm thinking here of climate-based irrigation controllers, things of that sort, and then even community irrigation scheduling. So for example, here in the state of Utah, our Division of Water Resources has this terrific resource, which is the weekly lawn watering guide that they run throughout the entire growing season every year. And this watering guide has been in place for many years, but this year they actually expanded it to include irrigation recommendations for low water use turf species. And that is because we've got some programs going in the state now to implement low water use species and varieties that have been wildly successful. And so now the Division of Water Resources is providing us some support there and helping people who install those species to irrigate more appropriately. And you can see that it's quite a bit less irrigation than for standard varieties. And this is just, I know that's teeny tiny, don't worry about it too much. This is just to show you the list of weather stations that are used to develop these weekly lawn watering guides. So it's based on a lot of data from across the state, and many other states have weather station systems that they use for this purpose as well. Now, related, there are some programs in our state, at least, for rebates of various types related to water. UtahWaterSavers.com is the place to locate those. And there are lots of different rebates, toilet replacements, etc. But we're really focusing on turf grass here. And so I would encourage local folks, at least, to check out this opportunity for getting a rebate for purchasing and installing a smart irrigation controller in your home. And we have conducted a number of studies here at USU to evaluate these controllers. I'm going to start moving a little more quickly here in the interest of time. But with these studies, what we found is that there can be savings in the neighborhood of 51%, 55%, depending on the controller, over what amounts of irrigation are typically applied. And so I am a big fan and proponent of these controllers. I think that they can help us a whole lot. And I also just wanted to mention that in these studies, we weren't just looking at the amount of water applied, because I am well aware that if people use these controllers and their landscape starts to look terrible, they are no longer going to be interested in using these controllers. And so we also monitored soil moisture, percent green cover, canopy temperature, basically landscape quality in response to these controllers. And I can tell you that we did not see a negative response in the 2 years of these studies that we conducted. So again, I'm a big proponent of these controllers. Now, we also provide support here in the state of Utah with water checks, and water checks are very detailed evaluations of home irrigation systems and landscapes. We have an online sign up, and the website is listed there, as well as a phone number that can be called. We have in-person availability to conduct water checks in the locations that you see there, but for others who may not be in those places, or maybe even are out of state who are interested in how we do this, we actually have an online tool to help you conduct your own water check. And it includes an online calculator, which takes the math out of it, which for most people is sort of the stumbling point. So if you live outside of those service areas, but you're interested in how you might do this yourself, I would encourage you to visit this particular website. And we also have, again, a different type of informational support for this purpose, with fact sheets that are appropriate for every county in our state, as well as a few cities. Now, I wanted to spend some time also talking about Turfgrass Dormancy. And that is because I get so many questions every summer when turf grasses start to go dormant about whether or not they're dead. Okay. And I get, is this normal? The answer is yes. Dormancy is an absolutely normal biological process that grasses go through to preserve the growing point of the plant for when conditions are better. And we've done some work here in Utah that I'm going to share with you now that has illustrated that with as little as 1/4 inch of irrigation per month, we can help grasses survive. They're not going to be green and lush, but we can help them survive through the summer months so that they can recover in the spring. And I just wanted to share this study that was headed up by our research technician, Paul Harris, looking at different amounts of irrigation. So we had 1/4 inch, 1/2 inch, or 1 inch of irrigation applied over once per month over the entire growing season. And you can see here, of course, that everything was dormant in August, but things started to recover in September and continued to recover into the fall. And we did have eventually complete recovery of these areas, even with 1 inch of one irrigation per month in amounts ranging from 1/4 inch to 1 inch. So pretty interesting results and a pretty strong illustration of the resilience of turf grasses. And in fact, I often think about grasses in our landscapes like virtual reservoirs, because when we can water them, that's great, but we don't have to, and they can be a source of conservation. And when conditions are better, they're going to benefit from natural precipitation like we've been receiving here lately quite a bit, and they will recover well. And this is just a graphical representation of those results, showing that by the end, everything was getting back to an acceptable level of green cover. Now, I also kind of want to wrap up with some information about turfgrass trialing programs. And there are many, many national turfgrass trialing programs. And we know, based on this as well as other research, that turfgrasses can be very functional in drought situations when managed properly, which is why I emphasized the management practices that I just did. And I would add that we have to start selecting, installing, and using low water use grasses that are identified through these programs, because it is the right thing to do in terms of water resources. It is the right thing to do in terms of overall sustainability, but we can still have these grasses and maintain those ecosystem benefits that I talked about in the very beginning. Now, the goals of these evaluations are to screen wide ranges of species and varieties for their response to both acute and chronic drought stress. And in that way, superior varieties can be identified for use in our landscapes. And we also use these studies to investigate the mechanisms of drought response for these species and varieties, and then companies that are associated and trialing programs that are associated can brand or market those cultivars for use for the purposes of reducing water use. Now, we participate with a number of these programs. I'm just going to quickly show you a few pictures of what this looks like. You know, we'll prepare a location, and then we will install small plots of the different experimental varieties that we are testing. They will be grown in. What you see there, I know there are quite a few weeds, but that's because as these are establishing, you know, when they're just small seedlings, we don't want to do any weed control that might damage them. And so we'll spend a year allowing them to establish before we do that. But then we might end up with a plot like this. This particular research we've conducted with the Turfgrass Water Conservation Alliance. They're a strong collaborator of ours. And for the projects we do with them, we actually have rainout shelters. That's what you see here in this image, with the purpose of excluding any natural precipitation. So in this case, this is a tall fescue trial, and I can tell you that that trial was remarkable in that we went weeks and weeks and weeks without irrigating these plots, and it took a very long time for the best performers to have a reduced turf grass quality. It was a very, very impressive study. And these kinds of studies, these are results from another TWCA study, but I just mentioned this and wanted to show you this because the way in which we compare these species and varieties is with digital imagery analysis. And we look at the percent of green cover and how that changes in response to drought. And then we can use software and statistical analyses to determine which ones are performing best. Now, some of these projects, in this case, this was an evaluation of different Kentucky bluegrass varieties, but you can see they performed, these are varieties along the bottom, mallard, bluestone, etc. But you can see the difference in water requirement over a 90-day period without irrigation. And you can also see the difference between the best performer, which was mallard, and the, I don't want to say worse, but the grass that used most water, which was solar green. But the difference in water requirement between these two varieties of Kentucky bluegrass was 53%. That is a huge difference. And so that's why it's important that we conduct these types of studies. Now, a more specific and application of this work I wanted to share with you is a project that we've been working on in cooperation with the Turfgrass Water Conservation Alliance in Salt Lake City, which is called Turf Trade. And this project, it's a public-private partnership, and we help the city to identify a mixture of low water use varieties of Kentucky bluegrass and tall fescue that they then were able to sell to their residents at cost with the support of our Center for Water Efficient Landscaping and the Turfgrass Water Conservation Alliance. So that project has been in place for a little while now. It has really, let's see, I believe at this point it's sold out 3 times, each time more quickly. But as a result of this program, there are now additional seed suppliers and sod suppliers in the state and more coming on board all the time. And so these are not hard to get necessarily, and it's no mystery what they are. We're very happy to share that. But the important thing is that this project and this demonstration portion of the project, which was conducted on a Salt Lake City municipal property, has been wildly successful. And we have created educational materials around what you have to do to establish these new species and made it this as simple as we possibly could. So mowing the existing turf short, using a non-selective herbicide to kill what is there, and then overseeding directly into the stubble and establishing that. So that's what the area looked like before we overseeded. This is what it looks like now. So this is how things had looked previously. We really tried to emulate what a homeowner might do. So we reduced the turf area to a functional level. We planted the lower water use turf varieties, and water use in this area in the year following establishment was 40% less than it had been previously. So again, just huge potential for water savings with programs like this. So I've covered a lot here today. I wish I had a lot more time actually, but water resource challenges that we're facing, and really bottom line here is how we can be most efficient with our turfgrass areas, how we can continue to reduce water use on those areas while maintaining those ecosystem services, which for me really is the bottom line. I guess I'll wrap up by saying that, I don't think we need turfgrass everywhere. Obviously we don't. But in those areas where we need it and where it has a function, let's do a better job so that we can continue to have those areas for play and recreation, and also be good stewards of our environmental resources. So I'm going to wrap it up there. I'll leave it on this slide just for a moment. If you want to check out some of these additional resources, I would encourage you to do that, but I'll take some questions now.
Thank you, Kelly. That was a wonderful presentation. And thank you everyone for being with us here. We do have some questions on the chat. Feel free to type in your questions in the Q&A sections, and I will read those out to Kelly. I answered some of those questions as best of my knowledge, but then David Wright asks, is there data on optimal mowing routine requirements?
Optimal mowing routine requirements. So I think
mowing and routing requirements. So how long should a route be, and how?
I see. Okay. Well, essentially there is a direct relationship between mowing height and rooting depth, but that rooting depth can somehow be sometimes be limited by the soil condition, right? So if you've only got 2 inches of soil above gravel, for example, that's pretty much the limitation of your rooting zone. So it's somewhat, I really emphasize soil preparation, and it is somewhat dependent on that soil condition. But essentially, it's a 1-to-1 relationship. The mowing height is the rooting depth, as long as there is no restriction due to the soil.
Awesome. Thanks, Kelly. And please type your questions in the Q&A box, which is then easier for me to read it out. Veronica asks, how well do these new cool season grass species handle heat?
They handle heat incredibly well. That project in Salt Lake City, so we planted that in fall of 2021, and the growing season of 2022 was only getting watered at the most once per week. And I don't believe we saw dormancy even in that grass. So it was handling the heat very, very well.
Awesome. And did you use machine to overseed it, or did you overseed it by hand? That's another question.
We just used a broadcast spreader. We literally put the seed in the hopper of a broadcast spreader. We ran around over the area evenly. There is a process to that. I mean, you want to make sure you have even coverage, but it really couldn't be much simpler.
Okay. And Janisha asks, similar to Frank, are there grasses that are best for overseeding less water efficient grasses? So are there grass varieties, I guess, that are better than other?
Absolutely, yes. And what you see here on this slide, and I'll take it down after I answer this question, but TGWCA, that is the Turfgrass Water Conservation Alliance, they have species and varieties listed that are proven to be lower water use. Same with alistturf.org and ntep.org, which is also leading a number of drought trials. But these are organizations that identify and then promote and encourage the use of these low water use grasses. And I guess my recommendation is just to make sure you're using certified low water use grasses. So all of these organizations work with universities like us to trial these grasses, and there are very, very strict guidelines in terms of how that research is conducted. So as long as they have been proven to be low water use, I would say that you're good to go. I would encourage you, though, to confirm your choices with your local county extension folks, just to be on the safe side, because I know there are people from a lot of places on the webinar. So
awesome.
Want to qualify that.
Yeah, that's true. And Frank asks, are your municipalities specifying and requiring smart controllers and low water use turf varieties for new development? Is that a mandate?
Here in Utah, it's really only been in the past couple of years, and I'll be honest, this is my opinion, but it's really been only the past couple of years that we've been getting more serious about water conservation here. Even though there have been a lot of people working on water conservation here for a long time, but it really wasn't, I think, until we've had not this past year, but not this year, but the two previous, we had the hottest, driest years on record. And our Great Salt Lake was really, really
low.
It was low, right? Lowest elevation on record. And that is extremely concerning to us here in the state of Utah. So to answer that question, since then, yes, there are some communities that are requiring it. There are some communities, I want to mention specifically Spanish Fork, Utah, that worked to provide those controllers to all of their citizens with the goal of reducing water use, and it was very, very successful. So the answer is yes, some definitely require climate-based irrigation controllers. As far as them requiring low water use turf, that I'm less certain of. That's been a newer effort for us, and I think it's, we're still working to get some uptake on that one, but I hope that happens, frankly. I think that will be a fantastic way for us to save more water in our state.
Awesome. So before I go to the next question, we have a survey. So once you close the webinar, you'll be prompted in a short survey. It's less than a page. So if you will all do that, that would really be helpful for us. And moving on to the questions, what was the savings on lawn you audited? I think 30%, right? 30 to 50%.
Oh yeah. Yep. When we do our auditing, which we call it the water check program, we've got consistent savings of 20 to 30%, which is huge. Having said that, I also think that if we can use that in conjunction with lower water use grasses and lower water use plant materials, it will help even more. So sort of stacking the programs to save even more water. But yes, it's 20 to 30%. And I'm guessing someone might then wonder, well, how long does that savings go on? And we've monitored our participants over time, and it tends to last for 7-8 years approximately. And then, of course, if the home ownership changes, that's a factor, but we get pretty consistent ongoing savings. Yeah.
So David Wright asks, from a research standpoint, would it be good to investigate the ecological benefits of lawn during midsummer and winter dormancy? Have you seen anything like that?
I have not, but I can tell you that I have embarked on new research just this year, and I will be doing that. It's really focused on climate resilience, and I'm going to be evaluating several different types of landscapes, including some that are turf, some that are not, and looking at all of the ecosystem services that I mentioned at the beginning with those landscapes, including what's going on with turf dormancy at various times of the year. So that's in the works.
Okay,
And
good to know.
Yeah.
So, like, just for the knowledge, 90% of plant, around 90% of plant for the turf is roots, right? So if we remove that root out of the soil, how much carbon are we removing from the system and sending it to the atmosphere? That is also a very crucial question, but
Yes, absolutely. Absolutely.
okay, so David, we'll have answers in a few years from Kelly. So Robert asked, how does soil compaction and effort to mitigate compaction affect water savings?
Well, that's a good question. Soil compaction is a problem for a number of reasons, but when soil's compacted, you get a lot of runoff. But compacted soil in a turfgrass setting also, it's not the physical action of, feet, for example, on our campus, feet on grass. That doesn't kill the grass. It's the physical action of the feet on the soil. And when that soil gets compacted by foot traffic or whatever traffic, it doesn't allow air and water movement into the soil to support plant health. Mm-hmm. And so if we alleviate compaction and we improve the microbial activity of that soil, as well as improving the air and moisture holding capacity of that soil, we're going to have better plant material. And that will improve the water use efficiency overall. But compaction, one of the major issues is with runoff. But also plant death, frankly.
Good. Thank you, Kelly. Yeah. We are nearing towards the end, but we only have 2 questions now, I guess. Can you mix warm and cool season grasses together?
Excuse me. Good question. We have tried that and so far not been very successful. And it's not yes, the answer is yes. But what happens is over time, one or the other tends to dominate. Right. And at least here in northern Utah, what happens is the cool season grasses tend to dominate over time. And it's because you can't really have a happy medium in terms of fertilizer, watering, etc., whatever inputs you're going to make that will work for both. And so you tend to favor one or the other. And then one or the other tends to dominate the area. If we could do that, that'd be great, wouldn't it?
Yes, yeah. That's right. So Renee asked, I don't know if this question is clear to me, but I'll read it out anyway. Bermuda grass grows well in desert, but it is replaced with winter ryegrass in the winter. That's, is it a comment or a question? Or
I don't know.
Okay. So if you would like to rephrase your questions, feel free. We still have 2 more minutes, but then one thing that hit my mind, Kelly, was like what if we let the turf like grow as long as it can in the first start of the season, so the root grows as well, and then you do what you do, like you keep it on your height, whatever you prefer. Will that help in root growth, or have you seen anything?
Yes, absolutely. Absolutely. And I also wanted to just share, I happened to be in Boston this past weekend for a meeting, and I was walking around the Boston Common, and there were several areas where they leave it unmowed. Mm-hmm. And that's a very, very well-used, well-loved park in this nation. I mean, it is, there were so many people there enjoying it, but, they have areas that are just left unmowed. And not every area, but quite a few, more than I expected. And I think a lot of it has to do with reducing mowing of those areas so that you're not having a lot of energy costs there, increasing the rooting depth of those areas so that they're better able to withstand any drought that may come along. But yes, you can do that. You can leave it unmowed. There's nothing saying you have to mow your lawn areas.
Awesome.
I will say, if I may, there are certain species that do better under that circumstance than others. So I just want to qualify that a bit.
Yes. So again, like we don't have any more questions. So if you would like CEUs, please email me and I will take care of that. Also, If you would like, please fill out the feedback, and that will help us to bring in presenters and what kind of topic people are interested in and follow accordingly. Kelly Kopp has her email in the chat. If you have any questions you can think of after this webinar ends, feel free to email her.